So I'm going to show you a very basic motion detection system that you can make using processing. A free tool. I'll have a link in the description for you to download it. You program in a Java derivative language. Very similar to Java though, if you know it. The one thing you will need to do though is download the in the tools section of processing. You need to download the video library because you'll be using the import processing.video. And just so you know how to get there, you're gonna, when you have process open, you open tools and add tool, and then you can go to libraries, and you could actually just select video from this drop down and find the one you want, and you can actually like select it. Mine's already installed, but if it wasn't, you hit install, and it should take a moment and install it for you. And then once you have that, so the way this system works, it's actually pretty simple. You capture, you're going to use the capture class in processing, and that comes with that download. And what we're actually going to do, what that allows you to do is to attach to your webcam on your computer, whether it's an external one or a built-in one, it should be able to find it. And so when you run a capture, you can actually take a series of still images from your webcam. If you string them together fast enough, it looks like you just have web video going, but you can actually just capture it and save it as an image, and that's why we have these two Pi image classes here, because what that does is it allows you to save it as an image, and it gives you some built-in classes for examining those images. And what we're going to do is we're going to take two different ones. That's why I have two different ones right here. And the first one's going to be kind of our base image. Basically, it's what the room looks like when you first look at it. And the second image is for comparison. We'll take a look and see if anything is different. And if nothing is different, we wait a second. Then we look at another image and do the same thing, compare them, see if anything's different. When we find a difference, we can declare movement. In this case, we're actually going to play an MP3 clip that says intruder alert. And then we start the whole process over by taking a pic and comparing it. So just to see what it looks like when you run this, it takes a second to come up, and you should see two images. And as I move in one of them, you hear that image there. And so the image on the left is the still image that gets compared to, and the image on the right is that actually keeps refreshing every second. And see, there's a difference in there between them. And that's how that works. It's pretty simple, but it's actually pretty effective. You have to tweak it a little bit to get it to work, but I'll show you what I mean by that. So, like I said, we capture an image, and once we have one image, then actually this is where we're doing it. We capture an image. If the camera's available, we capture it, and we make sure we save it as a Pi image as well. That's what's happening there. Once we have that first one, then the second time through, this draw here is just a loop if you're not familiar with processing. So the second time through, it'll see we already have one, and so it'll come back here, and if the camera is available, it captures a second image. And then once both images are set, they're no longer null, then we're going to go ahead and display them to the screen. And there's this built-in function called load pixels, which allows you to look at the individual pixels of these images. This is just a basic way of doing that. And then we'll go through 2 for loops and take a look at each of the pixels from each of the images, and pixel by pixel kind of examine them. It turns out you only need to really pick one. So you can look at the red, green, blue, the RGB of each pixel. And from experimenting with this, really you can just randomly pick one of these, the RG or the B. I'm just going to go with the R since it's the first one. And we're going to take a look. What we're going to do here is take a look at the R of the first image and the R of the second, and get the difference between them in absolute value. And I had to play around with this a little bit. If it was greater than 55, I determined, okay, that's enough. Otherwise, you could, from picture to picture, based on the type of sensor you have in your camera, you could get very variant light fluctuations that the camera allows in. So I came with this amount seemed to work well. That one, if it was greater than that, well, it was more than just the subtle difference in the light that the camera looked in. There was actually something more going on. And so every time that there was a difference in the pixels, I keep track of it. And then once there was a certain threshold, amount of pixels that were different, then I determined that we had movement. And actually, in this instance, it was 800. And once there was more than 800 pixels that were different, that was enough for movement. And you may have to play around with that for years, but it would probably be very similar. And then once that difference has been detected, I play the MP3 that you heard me play. And then we reset everything. Both images go back to null, and the whole process starts again. So that's it. I will share this code. Look for the link in the description as well. And hope you have fun playing around with this yourself. Thanks.